again, welcome to this channel. Today, let us know the relationship between the temperature and resistance of a material into two conditions. It means that if we are to subject our material in temperature 1, what will be its resistance? And you move that material to another temperature, say T2, what will be the value of the resistance of your material? So to be able for us to solve for that, let us know more better about the relationship between these two variables. I have here an XY plane representing the x-axis as my temperature and the vertical axis as my resistivity. Now, the temperature and resistance relationship is shown by this blue line or curve. It is somewhat straight line, but it is actually a curve. That is how the temperature and resistance relate. As the temperature rises, so also the resistivity. If it goes down, so also the resistivity will go down, so directly proportional. Let us again have this as our intersection point. We set this as our zero or the origin. Now let us consider a point here in our curve. Say this will be our condition 1, so it has a temperature of T sub 1, so it has also a resistivity of rho of 1. Now let's consider another point in this curve or line. Here we have the condition 2, so it has also T sub 2 and rho sub 2. So this will be forming a right triangle. This will be our hypotenuse and this one is our two sides. So the two sides are created by the subtraction of the conditions 1 and 2. Okay, for instance, for our resistivity, this will be rho sub 2 minus rho sub 1. So that will be the value. And for the temperature, you have T sub 2 and T sub 1. Now, we know in our trigonometry that these sides will be the slope of our line of the hypotenuse 1 to 2. So we can set up a relationship to be able for us to get the formula in solving the resistance at conditions 1 and 2. Okay, so now the slope, okay, we know that the slope is or m, so we say this will be the slope. So we can have this one, so that will be actually rho sub 2 minus rho sub 1, which is for our vertical length divided by the horizontal length, which is T sub 2 minus T sub 1. Okay, so in short, we can write this as the change in rho over the change in temperature. Okay, so this is our short method of writing rho 2 minus rho 1. We use this one, the symbol, which means delta. It means change. And knowing these relationships, okay, we know that our R, the resistance, is actually directly proportional, no? So shall I say like this symbol? Okay, it is directly proportional to the rho. So we can substitute here. Instead of writing resistivity, we can substitute here the resistance. So we can say that R sub 2, R sub 1 all over T sub 2 minus T sub 1. So therefore, this is also delta R over delta T. Okay? Now, if we are going to divide this one, this item or this term with R sub 1, we are referring to the what we call the temperature coefficient of resistance at condition 1. So it will become delta R. So I'm sorry, I just covered that. Delta R over delta T. So I'll divide this by R sub 1. Okay, so this term is actually what we call the temperature coefficient of resistance at condition 1, and it is represented by the notation alpha. Okay, so it will be alpha, so I'll put here 1. Okay, now knowing that, so we add R sub 1 here, so we can write here as R sub 2 minus R sub 1 over, okay, that will be divided by R1, which is T sub 2 minus T sub 1. Okay, or this is delta R over R1 times the change in temperature. So actually, this is alpha 1. Okay, so you can have an equation now between the two conditions considering the resistances. So we can write it like this one. Okay, R sub 2 minus R sub 1 over R sub 1 T sub 2 minus T sub 1, which is equals to alpha 1. And by algebraic manipulation, you can get R sub 2. So from here, we can have R sub 2. So R sub 2 is actually, if you are going to manipulate it, gives us this expression. So R sub 2 is equal to R sub 1, okay, plus R sub 1 and okay, alpha 1 T sub 2 minus T sub 1. Therefore, R sub 2 is equals to R1, so you factor out R1 here to be 1 plus alpha 1 T sub 2 minus T sub 1. Okay, so this will be our relationship. So if you want to get the value of your resistance at condition 2, knowing your resistance 1 and the temperature here at condition 1 and condition 2, okay, so this is actually subtraction, okay, and you have here a value for the temperature coefficient of that material, then you can solve for the resistance at condition 2, okay, and also you can solve many other variable here you want to get. If you are given the other variables, you can manipulate it algebraically. So that's it. This is the temperature and resistance into condition. Thank you for watching this video. I hope I shared to you an additional input to your knowledge, to your desire in learning subjects related to this. Thank you so much. God bless.